let's go ahead and get started. Tools and techniques for handling files with references. And I made the statement about the problem, the issue that we have. Well, here's what we're going to cover to talk about this issue. We're going to talk about what are file references, like break that down a little bit further. We're going to talk about really the biggest piece of this issue, which is the SolidWorks reference search routine. We're not going to go too far in depth, but I want to make it clear how much this can affect what you're seeing on a daily basis. We're going to talk about external references and handling with those, and then tools for changing references and copying files with references, and there's multiple tools in each of those. Now, the magnitude of the problem changes with the files and the file structure that we're dealing with. Let's just start with a simple SolidWorks drawing. Well, the SolidWorks drawing can have references in one direction to either a part or an assembly. The drawing knows where to look for that part or to look for that assembly. For those of you who are kind of new to references, SolidWorks doesn't embed all that data for the part file inside the drawing. What it does is it just creates a pointer in the header of the file so it knows where to go to find that file. So that's very simple. We can have a drawing pointing to a part or an assembly, but that assembly also has a pointer to the parts contained within that assembly. Well, there may be a subassembly within that assembly. Or what if you have an internal part inside that assembly? You can start to see these references get a little bit tougher. Now on the part side, if I've created a part, did I create it using mirror part? Did I use derive part? There's an insert part command. How about I did a split part to create it? So there's other things that kind of get in the way. Well, what if I used an externally linked design table? Or I've put in documents inside my design binder. All of these are references. All of these are things that need to be managed and organized. What if I've built parts inside the assembly and I've created references inside the assembly, which we're going to talk more about? So you can see just visually looking at this thing, it can get out of control really quickly. And for those of you who are designing on a daily basis with this product, this is something that you have to think about, and it really shouldn't be. So my goal today is kind of to make you a little more comfortable and to understand where to look, to understand what is happening when these things go on. Now I'm going to start with a tool you should be using on every file that you open, just to take a glance. It's called List External References. Now I call it the lost and found. It's a listing of what SolidWorks has found when it opened up a part, assembly, or a drawing. Okay, it's the paths to where it found the information. So let's just pop back to SolidWorks for a moment. Have a pretty healthy assembly open here. I want to know, now that it's open, where did SolidWorks find all the parts? Now I say that kind of tongue-in-cheek because in my company we have copies of files that are duplicated in multiple folders. I want to know that what I have open is the correct version. So if I do a file under the File menu, you have a command called Find References. Now what this is doing is it's telling you exactly the files that are open, where they're coming from. Now, what this doesn't mean is that the files that it has open are the ones that you're supposed to have open, or the ones that were referenced in the assembly the last time it was closed. And I'll talk more about that. Don't get scared yet. But this is what you're working with now. I now have a bunch of files coming from that particular directory. Now, my recommendation from this tool, use it each time you run into these issues where you say you have lost or missing data, you have mates that are blowing up on you, You have weird things happening where you just can't explain it, go to your find references and make sure it's pointing to the data that you expect it to. And which I'm going to show you here next is there's a possibility it found a file of the same name in a different directory. And if it does that, it could open that up here too, and you'd never know. A lot of times when you have mate errors, mates blowing up, it's because the system found a file under the same name in a different folder. And when it opens it up, the face IDs are different and the mates blow up. It doesn't mean that the old file isn't still sitting there somewhere. It just means that the system found it elsewhere. So first thing, file find references. There's a couple things in here. You can view it in kind of a flat view or nested view. We'll talk a little bit about broken references here in a moment. So that's the first step in the process, is to take a look at that. That's the lost and found. What did SolidWorks find? Now, what it finds is dictated by this process. Some of you have been SolidWorks users for many years. You're familiar a little bit with this. Maybe you don't have it memorized. My goal today is just to make you aware that there's some logic in the background of SolidWorks that helps you to find files. We call it the external reference search routine. Okay, it goes through a process. When you say open this assembly, it goes through a process of finding those files. Now that process consists of many steps, which I'm going to show you here in a moment. You see my little picture there. Wherever it finds these parts in this step-by-step process, it's going to grab it, the first one it finds. So it may find it in a location you don't expect. That's why duplication of files, having files of the same name, is such a problem, because the system can find it. So the first thing it's going to look for is in memory. So if the file is already open in SolidWorks. And then it's going to look in some of the system options. It's going to look in the path to the last document open. In other words, the path in which you said file open to the assembly. And then it has some recursive searching. It uses some other paths that you provide it essentially from the document open path to search through other drive letters and where it might have been. And then in the end, if it can't find it, it's going to give you the option to browse it. But if it finds it in any of those steps along the way, it's going to open it up, regardless of if it's the right one or not. So let's take a look at this process for a moment. So I've kind of simulated a couple different scenarios here. If I wanted to open up an assembly here, I just have a small robotic arm here. And when I open up the assembly, the software already went through that routine. It already went and looked in memory. It already looked in the locations where it was last stored. I have some choices here. I can browse to the file, or I can suppress the files and kind of move on. Now I'll have to suppress for all of them or say don't show again. And I'm going to leave this up so you can kind of see what's going on here. So it was unable to find any of the files, so it automatically suppressed them. Well, if I go to File Find References now, it just says File Not Found. Well, where was it looking for the file? Well, I can't tell from here. I know where the assembly was located, but I really can't tell from here. If you go to the suppressed part in the tree, you will have the ability to, in there, go to the properties of the component, and this gives you the document path that was saved in the assembly. So it's looking for this file under this reference search routine folder. Now if I just go to that real quick on my desktop, those files don't exist in this reference search routine folder. So it didn't find it. Okay, it obviously wasn't able to find it in the other spots, so it prompted me to browse for the file. Okay. Now, let's close that down again. Let's try this one more time. We'll go to the same file. Okay, double click to open. And I'm going to browse for one of the files. Well, I happen to find, you know what, there's the folder that this base frame is in. So let's go ahead and select it. Now, I'm not going to tell it where the rest of the files are. Okay, it couldn't find any of the files. But as soon as you provide it with one location, it's now going to look in that location for everything else. Well, guess what? It just found everything. Why? Because that's the folder in the search routine that it's going to look next. Well, here's the problem in this case. I have also a copy of these in another library. Well, let's try something different. Let's close that down. I'm going to just have one of those library components open. Let's open this arm here. Okay, so that's from my library, the other copied version of the files. And let's now open that assembly. Okay, it says, okay, I can't find any of these. I'll just tell it to suppress it. Okay, oh, it didn't. That's not what I was expecting to happen. KR6 arm. It should use what's in memory automatically. I may have changed the name. So you have to be careful. If we look back here for a moment, it will look and see what you have in memory, and it don't care where the location was supposed to be. It's going to take that part as well. Now, one of the options is the last document open path. Well, let's try something with that. If I take that assembly and I just move it into the folder that has components in it. Okay, and I go ahead and now just open that assembly. It found everything. Okay, even though the path in the file said it should have been in a different folder, it found everything in this folder because one of the options is to look in the last document open path. Well, that's where I opened the assembly from. So that's where it looked to. Okay. Now, what if I wanted to help SolidWorks find it? So in SolidWorks, we have in our options, we have the ability to add a path to look for reference documents. So if it can't find certain things, look here. Well, I'm going to go ahead and add a path, and I'm going to add my library because we use a lot of stuff out of that library. So I'll move that on up. Okay, now let's do a file open to that same assembly that's in that component folder, which the last time I opened it, it opened all of these parts. Okay, everything opens good. But let's go to my Find References. And look where it grabbed all the parts. It now opened the same assembly and parts from a completely different folder. Okay? We could spend an entire Lunch and Learn session going through every aspect of this external reference search routine. There's two things that I can say about this. Get rid of duplicate file names, period. Get rid of them. Whatever you have to do. And number two, make yourself aware of this process. There's a lot in the help. What this is going to do for you is be able to explain the unexplainable. When your mates blow up, you're going to be able to go to Find References and see that it grabbed the wrong file. And then you're going to be able to come in here and say, okay, what process did it go through? How did it find that? You're going to be able to explain those things using this reference search routine. And that's very, very important to do. Okay? So, reference search order is used whenever you do the file open. Now, it also looks for external references. These are external in-context references, references you create inside the assembly. And I want to talk a little bit about those because those do play a role as well. We're going to show you how they're created just so people have an understanding of what's done there. How to lock and break them. Okay, so to stop them from updating. And how do you create parts in an assembly without references? Okay, because a lot of people like to work in the assembly. Let's start with the ability to lock and break references. Well, first thing we want to do is we want to create an assembly that has external references in context to the assembly. So I've created a block with a hole in it. We've all done this before. When I decide to go ahead and insert new components in this, inside the assembly, it asks me what the name of the component is going to be. And then it asks me where I want to place that component. Now here's the very point in which we start to create references between part files inside the assembly. So as soon as I select that surface of the part, I've now created a relationship, a reference. And I'm going to show you that here in a moment. Well, let's go ahead and take that a little further. I'm going to copy the edges of that existing block. We'll go ahead and extrude that to some distance. We'll open up a sketch to be able to create the hole. And I want that hole to always match the hole in the bottom block, so we'll go ahead and convert that and do a through-all cut. Now, all I've really done is created files that work together, right? We've seen this. We go to 200, change that. It's going to update. If I decide to change the hole, okay, the hole in both parts is going to update. There's a lot of benefit to creating in-context parts. But if you can't manage the references and relationships, they're no good to you. Well, you can't really see what's going on through File, Find References. It's going to look a little bit weird to you. You're going to see, okay, I have an assembly. That assembly consists of two parts, B1 and B2. But then I'm going to see that assembly as a sub-item, a referenced item, almost like a part to an assembly. The assembly is going to be referenced to that part. Now, it doesn't tell you how. It doesn't tell you why. It just shows you there's something there. So find references, although it's going to help you with the files needed to open it, it doesn't help you to understand what's going on with these references that were created inside the assembly. You're going to use a different command called list external references. Now, the way I know that I have an external reference is the component that has the external reference will have this arrow next to it. You can kind of see where my cursor is. Now, there's two ways I can find out why that part needs to have other components to build itself. Either by right-clicking on the assembly, there's a command list external reference. That'll list for all the references in the assembly. Or if I right-click on the component itself, this is just for this component. And it shows me all the pieces that I reused. I reused a bunch of edges on an existing B1 part to create this feature B2 in B2. Okay, so it tells me what I need here. Okay. List external references is going to help you to get an understanding of what's going on here. And that's the reason why you have this reference that you're seeing here. Now, there's a couple other things in external references that we want to think about. Actually, let's go back to this one. There's the ability to lock and break references. Now, this is the component with references. Let's go to List External References, and let's select everything in the tree here. And let's use lock all. Now what locking does is it freezes things in place, so if you change one, the other isn't going to update. But as it tells you here, if they're locked, you can't add any new external references. When they're locked, you'll see the symbol added next to the arrow, this little star. Now what this means, if I want to go back to 50 on the whole, and I decide to rebuild, you'll notice that the other component does not update. Now, there's a possibility that things aren't correct, right, if something is locked. Locking is a temporary fix to keep things from updating dynamically. If I go back to list external references, I can unlock all of them, and as soon as I unlock, the updates will occur. It rebuilds in the tree. But why does it rebuild? What does it rebuild? If you right-click at the top icon in the assembly tree, you're going to see something called update holders. And this is going to play a role in what we're doing here. And I don't have any update holders here. Why not? I'll show it on a different part. These update holders are like features in the tree that it has to rebuild. Now this example will have some. These are two updates that it has to do inside the assembly in order to keep all the parts up to date. Now that can only happen until all the parts are in the assembly and positioned properly before this can update. Now most often they have this turned off, so you have no idea that there are these features inside the assembly that need updating. Okay, so list external references. Now what happens if I want to break those references? I don't want these parts to be related at all anymore. Well, I've seen people decide, let's just go ahead and break them. Well, once you break them, you can't get them back. That's the first thing. The other thing is you'll get this little X next to your external reference, maybe. And let me explain that a little further. This X in the past used to be a way of looking and say, hey, something's wrong. I got to clean it up. That used to have references and they're broken. If I go to my tools options now and go to my external references, SolidWorks now added this show X in feature tree for broken external references. In other words, show that they're broken. All right, show the X in the tree. But if I turn this off and reopen the file or Control-Q rebuild, you can see that the X disappears. Well, guess what? We're talking about references here inside the assembly, and now I'm looking at that. It's saying it has a reference, and when I go to list external references, it says they're none. So here's my next suggestion for anybody doing in-context design. If you're going to use external references and decide not to use them, like break them, don't break them, remove them. So my next point on the slide is, how do I remove references? I have an external reference still listed there. If I look down the tree, you can see I also have the arrow in front of both features. Well, let's start with the sketch. If I edit the sketch, what I'm going to do is look in my display delete relations and look for any relation that also has the external reference arrow. If I delete that, that removes the relationship to the whole. I may have to come in here and add some dimensions to position the whole to make sure it stays centered. But once I've done that, you'll see that the external reference arrow is now gone. If I continue to do this and remove them from all of the sketch items, let's try this. Use my display delete relations. Delete all. Well, I've went ahead and I was able to remove and get all my external references. Now if I were to change this, we'll go back to the 150. You can see that it does not update. There's no relationship. But I've removed the reference. There's no issue there. Now let's just check, and I didn't check this earlier. If I look back to my external references under Find References, you can see there's no longer a sub-item from the part to the assembly. Okay, so you're going to want to clean those up. Now, closing this for a moment. If we go back to that same assembly, some of you want to work inside the assembly and you don't want to create references. I want a block that sits on here that's the exact same size as this block, but I don't want to flip back and forth between the block and the part and measure and do all this stuff. Well, let's go through that same process, but I'm going to turn on a button on the assembly toolbar called No External References. What this allows me to do is work inside the assembly environment and not create references and relationships. So now when I insert a new part and I give it a name and I place it on a face, it doesn't create a reference. If I tell the software I want to copy the edges, it's telling me this would create a reference, okay, because I've turned off this. Well, I'm going to say don't show it again and say okay. It still copies the edges. They're just undefined. Now I can come in here and set the actual size with some dimensions. It's going to be the exact size of that previous block. Okay? And the same thing goes for the hole. But I'm able to build parts inside the assembly and not have those external references. When I go to my file, Find References, I don't have anything extra added there. Now I bring that up because I think a lot of people would work inside of an assembly if they didn't have to worry about the relationships between the parts. Well, there's a way to do it. Okay? So the other key to that story is that don't think that File Find References is going to list your in-context references, your references inside the assembly. Okay, those are just as complex, but are kind of in a different location. Okay. So what if I want to change references? I've put together assembly, and now we've got a new version of a cylinder that we want to use, and I don't want to use the one over there. I want to use the one over here. What tools do I have to do that? And I want to explain these in pretty good detail. Well, there's 4 that come to mind. There's actually 5, but I'm going to show the other one a little bit later. We can use File Save As. We can use File Replace. We can even use File Open to change references. And then our favorite tool, which is probably the most organized tool, which is SolidWorks Explorer. So let's go into an assembly for a moment. And let's say I wanted to do a Save As. And let me just check something for a moment here. All right. I'm going to turn off an option to show you what you might be seeing and running into. If I take this plate and I open it up and I say, you know what, we're going to create a new version of this plate. So I open it up, I perform a Save As, and I have 2 choices. Most of you have heard this for quite a while. I can save it as a new name, or I can save it as a copy. Now, saving it as a new name is very similar to save as copy, except for one thing. If you save it as a new name, any files that are open that are referencing it will now refer to the new name. Well, let's try that. Okay, I'll call this Plate 2, and we'll put this on my desktop and save it. Okay, so now I have Plate 2 open. You can see that Plate 2 is open. let's go back to the assembly for a moment. If I look down the tree, it doesn't look like plate 2's there. Well, let's go to File, Find References. Let's see what we got going here. And still no plate 2. Oh, there's plate 2 down there. Find References, update plate 2, but it's not in my tree. Again, these are the situations that make it very confusing to deal with references. Now, the reason why that doesn't work is because of that option I was working on here turned off. If I go under System Options, under External References, there's an option in here which I still haven't figured out why. I think it has to do with the routing. There was something there. But update component names when documents are replaced. Let's try that process one more time. So let's open the part, do a file, save as a new name. We'll call this plate 5. Save it to my desktop. Because the assembly was open, it should update any reference in the assembly, and I now have plate 5 inside the assembly. Okay, so you need to be aware of that option. Now let's grab another part here and do the same thing. What if I open this part and I decided to do a save as, and I want to just make a copy of this part under a new part number. Now this is another gotcha that you need to be aware of, and you probably run into it. But let's save it as a copy, save it to my desktop. I can give it a new part number or whatever. I went save it. Now, most times when I see someone using that, they do the save as copy, and then they start to modify what's here, because they think that they've just made a copy. So they're not working on the original. So they went and made a change in the design, and now when they jump back to the assembly, guess what? The assembly's changed. Well, I made a copy. Well, let's just review that for a moment. Let's just open a part here. File, save as copy. Original file will be in memory. The copy with the new name will be unopened on disk. I have seen so many people make copies and not realize that the file doesn't get opened. You actually have to close the old one and open the new part number in order to start modifying and making changes. Again, dealing with these references can be a little bit tricky. So I can use file save as to swap part names out. That's not a problem. Well, what about file replace? Well, that's very similar. I can find the part I want to replace inside the assembly, use the replace components command, browse to the one I want to replace it with, and the software is going to go ahead and do the replace for me. If it can match up the mates, it will. Otherwise, you might have to fix the mates. So I can change references that way. If I go to File, Find References, you'll see that in my references, I do have a new location in here for the new part. So I can start to change things around and reorganize and swap parts. The problem with that method is a lot of times the mates aren't going to be recreated, really depending on how the part was created, whether it was a copy or something new from scratch. So what about file open references? How can I change what a file is pointing to just in the file open screen? I'm going to use a different example for this. Something a little more simplified. Now, I have a drawing. Let's see here. If I open it up, a drawing of a part. Well, now I have another part that is completely similar, maybe has some new holes, but I need a different drawing for it. Well, I can easily do what we just talked about. I can do a save as copy. I'll call this DME2-A, whatever I want to call it. Alright, and you can see that the sheet is open, but if I do my file find references, it's still pointing to the original DME2 plate. Well, let's close this down for a moment. In the File Open dialog, if I go to the drawing that we just created, you're going to see a button down here for references. What this allows you to do is to see, kind of just in the same method of the file find references, to see all the file paths that the part is pointing to. Now this is another great way to see where it's looking for all the parts. So if you do a file, it doesn't find the file, you can use this to find out where it's looking for it. But in this case, I don't want it to point to this DME2 plate. I can actually double click on the folder and have it find the new plate in here. And I can actually browse to what that plate actually is, the parts. So when it turns green, it's updating it. I can go ahead and say OK, and then open the drawing. If I do my file find references now, you can see that it's now pointing to the DME-E plate for this particular drawing. Now, you do have to remember, in order for it to stay updated, you have to save. Otherwise, it doesn't update it. It's just on that file open. Hit the save to actually update the drawing. Now, anytime you open it, it's going to reference that particular part file that you just changed it to. Okay? So you can use the open screen in SolidWorks to change references. Again, you kind of have to be very aware of what you're trying to do, but you do have the capabilities to be able to do that. SolidWorks Explorer. How can I use SolidWorks Explorer to change references? Well, let's launch this tool. Now, this is a tool that if you don't have a PDM system, you should be completely familiar with how to use this tool. This tool is what's going to help you be able to make changes to files and have it update other files. So let's just go to my documents we were working with here, and I have one of my assemblies. If I select the assembly in the tree off to the left, I do have the ability to see the references for that particular assembly. But I want to change the name of one of these components. Well, here's where it starts to get very tricky. I don't know where that part's been used, if it's been used on multiple assemblies. I don't know any of that. Well, I bet a lot of you are saying, you know, if you can't figure that out, you're making a copy of it and giving it a new part number. With SolidWorks Explorer, you have kind of the next step of tools to help you figure out where it's used, to help you get things updated. If I were to right-click on that component, I have the ability to perform my renames, my replaces, and move components from folder to folder in here. Now, if I decide to do a rename, it brings up a dialog where I can type in the new name. But there's another part of this tool that's important. We can tell it to update the where used. It knows that it's used in this assembly because it's looking in the same folder. It found one document in that same folder that's using it. But guess what it doesn't do? It doesn't search your entire drive to find out how many other assemblies used it. So the next time somebody goes to pull assembly that was using this old part number and that part number's gone, it's just going to say file not found, like we've been talking about. With this tool in SolidWorks Explorer, if you go to the options, which is this little third icon at the top, we can tell the software where to search to find any other models that are referencing the one I'm going to change, rename, or move. So I can add a folder path anywhere on the server Now, it may take some time. It's got to search through all these files and say, hey, is this one using it? Is this one using it? Okay, but when you do that, you can perform a rename, give it a new name, and it's going to update the references. Okay, that assembly knows it's using this particular part, and the part's a different name. If you haven't used Explorer, I suggest you try it. If you have a PDM system, you don't need Explorer. Explorer is obsolete. You don't need it. Okay? Continuing on. How about copying references? You know, we've talked about all the different ways to create it and how to look at it, but what if I want to copy references? Well, most of you know about the first one, which is pack and go. Pack and go, the ability to, you know, put everything together in one spot and make a copy. The problem with copying with pack and go is people are just making copies and making changes, and then you have files of the same name in different folders. Okay, that's what creates the risk where your SolidWorks can find folders of a different name or files of a different name. What about if you wanted to copy assemblies with in-context features? I'm going to show you a little bit with that. Let's start with pack and go. So taking our same assembly we've been working with here, I want to gather all these parts up and I want to make a copy of them. Now, since we're following our own rules, we don't want the same name. Well, how do I get to pack and go? Well, if I go under the File menu, I have the option for pack and go. There's another way to do it, which I like as well. If you go to Find References, if you hit Copy Files in here, it takes you right to pack and go as well. Now, pack and go is nice because it also can look through the system and try to find any drawings. Okay, now this isn't going to do a search on your drive. It's really just looking in the folder to see if it found any drawings. If there's any simulation results or toolbox components that are part of your toolbox library, it can go ahead and wrap those up as well. But the pack and go tool does allow you to give new names to the resulting parts. Okay. Now let's go to my desktop here and we'll make a new folder. We'll call this my new assembly. And what we want to do is we want to save some of these components to this new assembly folder. We're going to create a new assembly and we're going to change this 1113 part. Well, this checkbox tells us how many that I'm actually packing and copying. Well, let's just turn them all off. I'm going to make a copy of that one and that one. The name, we'll give it a new name, AD2, and we'll give this a new name. Just by double-clicking in the path, we'll call this PT2. Okay. Now, when I do save, it's not saving every single one of these parts. It's saving the two that I need the new part numbers on. Go ahead and save that out. I can close this, close this. Now when I do a file open and I find my new assembly folder, I should have the two that I need. If I select the assembly, remember I even have the references button here. Hey, you know what? Even though I made a copy of the assembly and the part, I still have all the references to the parts that I'm reusing from the previous project. So I can still open this up and have a completed assembly without having to make a copy. And if I go to my file, find references, I can clearly see where everything is coming from. I have my new part in my new assembly in my new project folder and everything else I'm sharing. Okay? Now, having done this for a while, I don't think these tools are being used. I really think copies are being made, and that's what's causing a lot of strange things to happen on your assemblies. Save as with references, going to do very similar stuff. So now I have 82 with my new part in there. What if I did a file save as? In the save as screen, there's also a references button. Now this is almost exactly like Pack and Go. I can now save a copy of this assembly, and I can set it to a new folder and give it a new name. So maybe I want to call this AD3. This thing gets a little, so AD3, and I'm going to create a new, we'll put it in the same location. So you can do your renaming like we did in the previous one, right in the Save As and hitting References button. And it's only going to save the ones that we've made new part names for. So it is just like Pack and Go, an option. Now, for those of you who are creating in-context parts, you've probably run into this next one. I want to take a part that has external references inside the assembly. You can see my external reference icon. What if I wanted to make a copy of this assembly? File, save as, my desktop, give it a name. All right. You're going to get a message. There are parts inside this assembly that have features that were built inside the assembly. It's telling you that the resulting assembly, the copy, is not going to update. Well, if I've went through this process of building an assembly that updates, I want my new one to be able to update as well. But here's the issue. We don't want it to update based upon this assembly. I want it to update based upon the new assembly. Because if I change it here, I don't want it to change in both assemblies. I want it to act unique. So this file save as copy isn't going to work here. Here's where you would use file save as and then select references. And what you're going to do is you're going to save a copy of the new assembly and a copy of the part that is going to be updated based upon the other two. Now, here's the reason why that does that, and it's very simple. When you do a save as copy without copying the parts, these update holders don't get copied along with it. So there's no way for it to update the features between the components. Okay, so save as with references and select what you want to save out. Now, this entire conversation is geared towards those folks not using a PDM system. As you probably are already feeling, it's a little bit overwhelming. There's a lot to think about, a lot of things you don't want to think about. And I want to kind of close this with a little different message, because really you don't have to think about these things if you put a PDM system in place. What we just went through is what a PDM system does for you. A PDM system allows you to name and move and do all the updates and gives you tools for making copies. Okay? It makes it easier, better. It makes it so you can't have duplicate file names. Okay? It eliminates a lot of this. Now, the reason I felt this was a good lunch and learn, because not everyone's using PDM yet. I hope someday everyone is. But right now, using the tools in SolidWorks, it's not surprising to me that you have mates blowing up, changes disappearing. Well, changes disappear because the part that you changed is not the one that SolidWorks opened up because it found a duplicate. I challenge you from here forward. If you start to see these strange things, go to File, Find References, and see what happened. Chances are 90+% of the time you're going to be able to find out that it grabbed something it didn't, or it shouldn't. And you're going to be able to make the fix and go find the correct file. Yes, it's going to take some time to think about, but if you make yourself familiar with this, it will help you going forward. Well, I want to thank everyone for attending today. I hope you enjoyed it. The recording will be on the website, and you can review this at your leisure.